Hello everyone, welcome to another video of OD Tutor. In this video, we will discuss about what is Ohm's law. So if you want to learn what is Ohm's law, this video is for you. Ohm's law is a fundamental principle in electrical engineering and physics that describes the relationship between voltage V, current I, and resistance R in an electrical circuit. It is named after the German physicist called Georg Simon Ohm, who first formulated it. Ohm's law is expressed by this particular equation V is equal to IR, where V is the voltage across the conductor, which is usually measured in volts. I is the current flowing through the conductor, which is measured in amperes, and R is the resistance of the conductor, which is measured in ohms. This equation indicates that voltage across a conductor is directly proportional to the current flowing through it and the resistance of the conductor. So as you can see here, when you will increase the current or if you will increase the resistance, voltage will increase. So this simply means it is directly proportional to the current flowing through it and resistance of the conductor. In other words, if you know any two of these values, that is voltage, current, or resistance, so out of these three values, if you know any two values, you will be able to calculate the third value. Let's see this circuit here. You can see this bright bulb which is lit here. So we are using this particular simulator from PHET. It is phetcolorado.edu. So in this circuit, first of all, let's create a circuit. So let's first have an AC voltage source. So let's say this is an AC voltage source. You can imagine this AC voltage source as outlet of your household, any outlet of your household in which you plug something. Now we will take a wire and connect this wire to its one end, and then we will take another wire and connect it to the other end. This is another way of simply putting wires in your household socket, like the electrical socket that you have. If you plug something, let's say these two wires are the wires of a plug, and let's say we also have a switch here. Okay, this is your switch, and we have an electrical bulb, and let's join this switch with this bulb. When we will turn this switch on, then you will see the bulb is glowing, and because the circuit is complete. Okay, so here you can see. Now let's click on this to show the values. Okay, here you can see the bulb is glowing, and since it is an AC voltage source, so we will drag voltmeter and we will try to measure its voltage. In AC we can apply these positive and negative terminals to anywhere, and you will see the voltage going from -8 to +8. Okay, this is the voltage. We can also try the same experiment with a DC voltage. So let's bring in the DC voltage and let's remove this, and this battery will give us a DC voltage. So let's connect it. Now you can see a DC bulb glowing, and here you can see the flow of electron. In AC voltage, your polarity changes with every second, right? So let's say the frequency is 50 Hertz. So it simply means the polarity changes 50 times in 1 second. So, but in case of DC, there is no polarity change, and you can see the current is flowing from positive to negative terminal. This is the positive terminal, this is the negative terminal, and hence when we will connect positive and Red is always positive. So when we will correct the positive end of the voltmeter, you will see we are getting a positive 9 volt. If we reverse it, we will see minus 9 volt. So this simple experiment lets us know how DC and AC work. But in this case, you can see because we have no resistance, so as per our equation, we only have V and we only have I. We have some current flowing through it, but there is no resistance. Let's measure the current. So using an ammeter, we can measure the current, and you can see the current is 0.90 ampere. Okay, voltage is 9. There is only one resistance here in this circuit, and that resistance is resistance of this bulb. So whenever we apply an electric load to any electric voltage source, in that case that electric load has some resistance of its own. So now V is 9 and 10 times 0.90 is actually 9. So let's take this equation. So V is equal to IR. What is V? V is 9 volts. Current is 0.9 amperes and resistance is 10, which simply, so in our case 10 into 0.9 is 9. That's why LHS is equal to RHS, and hence it proves the Ohm's law. Now to make this circuit more interesting, what we can do here is, let's remove this thing and let's put a resistor over here. So we have another resistance of 10 ohm. Now what happens is, we in our circuit we have added 10 ohms resistance. So now the total resistance, since the resistance is added in series, if you add resistance in series, it will always add up, because now the circuit has to go through this resistance. This is the simple thing. So now the total resistance is 20 ohms, and as per our principle of V is equal to IR, voltage is same, 9 volts is equal to, we know the resistance, that is 20 ohms, but we don't know the current. So current will be nothing but 9 divided by 20, which will come to 0.45. This is our calculation. You can try that. Now let's use the current meter here to analyze it. You can see 0.45 ampere. It simply proves that, it proves two things, that when resistance are added in series, then their resistance adds up, and hence the total resistance is 20. And the second thing is, which it proves, is V is equal to IR. So under normal conditions, without any external factor, voltage applied in a circuit is directly proportional to the current flowing through it, and it is also directly proportional to the resistance. This was our simple description of Ohm's law. You can try this simulator. You can see the URL here, and you can try playing it with yourself. Let's say we want to include more resistance, so let's cut it. Let's add more resistance here. Now you can see the because now resistance is 30 ohms. In this case the current will be 0.30 ampere. In next chapter we will also teach you how to calculate resistance when resistance is connected in a parallel circuit. So here you can see this is an parallel arrangement of resistance. We will use another resistor here, and you can see, and if we apply a battery here, you can see, so if we apply a battery, So you will see, because battery has a voltage, the current has started flowing through our circuit, right? First let's cut it, let's make it proper. Yeah. So now you can see, in this case, when you will measure the voltage at this end, you will see voltage is minus 9 volt, because this is negative terminals, and now voltage will be plus 9 volt. So in this case, the overall resistance of this circuit will be different. So in the next video you will learn how to calculate voltage, how to calculate resistance of a circuit when it is connected in parallel. So stay tuned for the next video, and for more educational videos like this you can follow our channel OD Tutor.